numbers to work through. When we're dealing with an arithmetic, everybody's got different eyes at the same time, that's funny. When you're dealing with an arithmetic sequence or a series, that means that there's some common difference within the numbers as they're going up and or down. So we deal with it in terms of that. Excuse me. Getting better. Quite dead yet. So within arithmetic, there's a common difference between terms. This is how we're able to tell whether or not it's going to be arithmetic or, when we talk about tomorrow, what's called geometric. A geometric is going to have a common rate. So there's a multiplier. Versus this, there's some adding or subtracting. It's actually pretty simple to work with when we go through it. There's a common difference. We use the lowercase d for that. And it uses, what we want to do is, first of all, tell whether or not things are going to be arithmetic. And the way that you do that is you're just looking at the relationship as each number in order. Going from 3 to 1, you go up or down? I'm sorry, -3 to 1. Go up or down, how much? You went up 4, up 4, up 4, up 4. So what would the next one be? Then, and so on and so forth. That would be considered arithmetic because you're going up by the same amount each time. Or you could go down by the same amount each time. It means the same. Like I said, pretty straightforward. The next one you go up 3, 5, 7, 9. I don't believe that is arithmetic because the difference isn't the same each time. It changes. Could we still figure out the pattern? Yeah. We could probably come up with some sort of a rule and work through it that way as well. But when you're looking at it in terms of just straight, is it arithmetic? No, it's not. And I know you guys could probably figure out the next term. It's going 3, 5, 7, 9. The next one will be up 11, up 13, and so on and so forth. So whether or not it's the sequences of just recognizing pattern, or is it going to be more specific that you're recognizing that it is what we call arithmetic? Right? Not too shabby. Bring it. All right. So we have this rule for the sequence, and this is, now I realize this is what you were talking about the other day. We're like, oh yeah, we got that formula. Well, there was one, it was just the wrong section. So that's what happens when you have a head cold at 4 o'clock in the morning trying to figure out what to have you guys do. Where we get this done, a sub n, where it just means the nth term. Any term within the sequence can be defined by the first term plus the number of terms in the sequence, that n value minus 1, times the difference. So if we look at that sequence we had up there a second ago, where it was -3, 1, 5, 9, what was that, 11, ... If I wanted to write the rule for that as in like a generic rule, all I have to do is identify what's the first term and what's the difference. What's the first term? -3. So what we would do is say it's -3 plus n minus 1, and what was our difference? 4. Distribute out and rewrite. So it would be 4n minus 7 would be the rule for that sequence. So then from there you can say, hey, what's the 25th term, which apparently you guys were doing anyway. So now it kind of makes sense of what you were doing, even though you probably didn't know what you were doing. Right? Yeah. Notes are always so happy, I appreciate it. Wow. Should we make this more difficult?
No.
Sure. So let's write the rule for the nth term of the sequence, given the fact that it goes 50, 44, 38, 32, and then we're going to find the 20th term. So when we write out the rule for the nth term, just like I did a second ago, we always simplify and put, put it in descending order like you would any other equation. So we have the formulas. A sub n is your first term plus n minus 1 times the difference. That's the first one we're looking at. We got one other formula to look at here in a little bit as well. What's the first term? 50. What's the difference?
Minus 6.
Minus 6, very good. It's very important that you make sure that you use your negatives if it's a negative d value. So it's going to be 50 plus n minus 1 times negative 6. Distribute and combine like terms.
Where'd the 6 go?
I was checking to see if you were paying attention.
I was so
Good word. Never make mistakes. Actually, I was looking at it going, why is it not equal to 50 for the first term? Yes, ma'am.
You always have to write it so it's
Yeah, that's the more etiquette way to do it. Just like you would write any other equation in descending order. That's just how you would write it out. Okay. And that's basically how we do this for arithmetic. If it's not going to be an arithmetic sequence, we can't use this formula. It only works for one of them. Now, the other thing that's nice is that you can use your calculator in the y equals in your table to see if you did this correctly. Because if you did this correctly, your first term should be 50. Your second term should be
4.
So should you ever get any of these questions wrong?
No.
No, you should get ace this test. All right.
Time factor.
What was the 23?
negative.
Oh.
It's 64.
You're
Wait, no, I'm wrong.
60. Wait, hold up.
I'm definitely wrong.
Okay.
So negative
Negative 60.
120 plus 56 is
negative 60.
negative 64.
Did we really have to do that?
Well, it said two. I just.
Well, I did it in my head.
We have
so I'm
to.
proud of myself.
Yes, ma'am.
Since it's a few terms, shouldn't it be like -6 or -19?
It's the end. Once you put it into this format where when you simplify everything out, the end value when it's written out as -6 times n, that means the nth term. That's what you're looking at. It's the 20th term. Yes, we reuse the rule. I mean, if you went back into here and used 20 into that, it's going to get you the same way because that's a 50 and there's the -6. It's going to get you there. Yeah, always use the rule that you come up with. So sometimes you want to write the rule if you're given a term within the sequence and just the difference. You just don't know where you started from. So you're going to manipulate this equation. You're going to be given, well, we have 1, 2, 3, 4 variables. Think about it. You're going to be given 3 of those 4 or 2 of those 4. And you'll have to figure out the other ones by using algebra. I know, I've heard about it. I heard it's pretty cool. So we know that the 13th term is 30, and the common difference is 3/2. The generic formula for the arithmetic sequence is a sub n is excuse me, our first term plus n minus 1 times our difference. Well, what's n in this case? 13. So I know that the 13th term is going to be the first term plus 13 minus 1 times 3/2. What is the 13th term? 30. What I did there was I took an extra step between these two parts. Because I was given the 13th term, that means my n value is the nth term as 13. So I wrote out a sub 13 is blah, blah, blah. But then I knew that the 13th term was 30, so I wrote it after. Do you have to do it that way? No, but it kind of helps to set up the problem a little bit cleaner. So what's 3 halves of 12? 18, good. So 30 is your first term plus 18. What's your first term? 12.
12.
Good work, it's 12. Way to keep up. Are you done?
Now.
No, because it told you to write out the rule. Now you just go back to write out the whole rule with the first term and your common difference. Yeah.
Is the n in the equation is the n,
Yeah.
but it's not like going to 13, but it's the term.
Right, it's the 13th term in the sequence is 30. So you go back, you start over again. And you fill in the blanks. 12 plus n minus 1 times 3 halves. And then you distribute through. So let's see here, we get 12 plus 3 halves n minus 3 halves. So if you had $12 and you took $1.50 away, how much do you have? $10.50, otherwise known as there you go. And then obviously, once again, you may not have all the terms written out because you don't have like a list of 5 of them or whatnot to double check your work with. But could you take that equation, just substitute in the 13 for n to see if you wind up, getting 30? That's all it is. That's all it is. Excuse me. Not very frightening? It's very exciting. Just wait till we play cards. You guys are gonna love that.
You always tell us that, you never.
We're getting there. We're
Blackjack?
almost there. We're almost there.
Blackjack?
Maybe. Yeah, we're okay. We have time. Wait, I can't imagine this was tough. What's your difference?
15.
What's your first term?
32.
So the nth rule is going to be the first term plus n minus 1 times your difference. Top tip for today, write it out every time you use it. You know why?
Why?
You'll remember it.
Yeah, nice.
So let's see, 32 plus 15n minus 15 gives us a 15n plus, what is it, 17? And then I want to find the 12th term. What do I do with the n? Substitute in 12, so let's see, 144 and 36 is 180? 180 and 17 is 197.
Yep.
Yes.
Oh.
Can you do that, Kobe?
No, I can't do that.
You think you can count cards?
You can't count them.
All right. Let's find a given 2 terms. Let's write the equation knowing that you have 2 terms in a sequence. This is where it gets to be a little bit tricky. You have 2 terms in a sequence where you have the 6th term is 10, and you have the 21st term is 55. So what we need to do is figure out the difference and the common first term.
I got this.
So here's what happens. When you're given 2 terms in a sequence and you need to write out the rules, what we're going to do is create a system of equations. We're going to write out 2 different equations. Nth rule is first term plus n minus 1 times our common difference. I'm gonna substitute in 6 for n and write it all out long form. So the sixth term is gonna be the first term plus 6 minus 1 times d for our difference. In this case, what is the sixth term? N. So this is gonna wind up as our first term plus 5 times d. You all right with that so far? 6 minus 1.
Oh,
Do the same thing with the other side. Write out the rule. Fill in the blanks. 21st term is our first term plus 21 minus 1 times d. So it's 55 is first term plus 20 d. These two equations now can be set to eliminate one variable. What is going to be the easiest one to eliminate?
D. A1.
A sub 1.
Oh.
Watch what happens. If I set this underneath here, if I do a system of equations via elimination,
Minus.
I just subtract everything out. Won't that, doesn't that first term eliminate itself? So what we do with this stuff is 99, well, all right. You're always going to solve for d first because your first term doesn't have a coefficient. And it's going to be the same for both equations no matter what because they're in the same sequence. They had to start at the same place. So you eliminate via subtraction. 45 is 15d. What's d? Great. You all right? Yes, ma'am.
Couldn't you just find the difference between 6 and 21 and then do like 45 divided by
It works. This is a more concrete way because sometimes you'll have negatives and stuff like that, but that works. It does work. So now if I know if my d value is 3, I just come back up. And what's your first term? Negative 5.
Wait. What?
15, subtract it out, get negative 5.
Oh, I thought you said 95.
Oh.
No.
And then you just write it out. So you know that your final thing, whatever it's called, equation, thank you. Now you have your first term, common difference, fill in the blanks. So we get 3n minus 8, I believe. That gives us our rule. But wait, there was one other little part up there. But wait, there's no. It slices, it dices, it juliennes fries. That's an old infomercial. What value of n will give you 40? What value of n is going to give you 40? 16. So if you're trying to figure out what n is, make it equal to 40, all I do is take my last equation and solve for n. Tomorrow it gets a little bit crazier when you do the geometric with two different values. You have to actually use a logarithm. It's really easy because you guys actually know what a logarithm is, but I hope you remember that.
I know log will have to right after base 10.
Was it 16?
Yeah.
So the 16th term would be 48. What happens tomorrow is sometimes you're going to get, when you have to get the exponent, when your variables is an exponent, you would take the log of both sides. What would be the log base of both sides I would take for that?
Good.
It would just be log base 5 on both sides. That kind of stuff. We did that a while ago. It comes back with sequences in series, especially with geometric. It's one little quick step that we'll do.
Just the log 5 and the 5.
Right. Log base b of b to the x is x, and so on. And then it'll be log base 5 of 5 to 3. 5's dropped, 3 to 3. But we do that again in form. This sum, the series, here's the other formula for today. We did the sequence and then we have the series. To find the sum of so many of them is going to be, what is it? We got the number of terms, of however many terms you're trying to add up. First term plus the last term that you're looking at, divided by 2. So what we're looking at is the sum of however many terms you're looking for, whether it's 3, 6, 47, 132. That end value is however many numbers in the sequence you're trying to add up. So you're going to look for the first term and whatever the last term is in that sequence, whatever that end value is. You might not know that right away. You might just have the generic rule and you have to figure out what that last term is. And then you just multiply it out. It seems weird at first, but the algebra that we do for this is really quick. It really is. So let me show you an example. So I want to look at the sum of the first 30 terms of this sequence. 4, 7, 10, 13, 16, 19. So I want to find the sum of 30 of them. The easiest thing to do in these cases is to always write out the rule first. Write out the nth rule just because you're going to use it anyway, so you might as well do it. So you know what your first term is. You know what your difference is. Your first term is, difference is, so we have first term plus n minus 1 times your difference. We know it's going to be 4 plus n minus 1 times 3. So we get 4 plus 3n minus 3. So our nth rule is 3n minus 1, excuse me, plus 1. It doesn't take long to do that, but believe me, you're going to use it later on, so you might as well just write it out. So we want to figure out the sum of the first 30 of them. Now, I'll come back to this other part here in a second. So the sum is going to be the number of how many we're trying to find, first term plus last term over 2. We're trying to find the sum of 30, which means I have to find the 30th term. Well, good thing I wrote out my rule, because now I can figure out what my 30th term is. That's why we do that. Right. It doesn't say you should, but it's a lot easier. If I got to figure out what the 30th term is, well, that's going to be 3 times 30 plus 1. Weird. Wasn't even trying to do anything. So what's 3 times 30 plus 1? 91. So the 30th term is 91. What's the first term? 4. So, what was it?
1,425.
So the sum of 30 then is 1,425. I thought for some reason I thought it was 35. Remember, you're dividing by 2. So if you're going to write this out in your calculator, use the fraction bar with parentheses, or just take half of 30 and multiply it times 95. Don't try to do it all at the same time, because you'll be wrong without parentheses. Okay. Fairly simple. Okay. Now, figure out how many of them you had to add together to get a sum of 175. Okay. When we go this route, again, we are using the bring this part to the other side. our rule was what? 3n plus 1? The sum formula, the sum of so many is so many first term plus whatever that last term is over 2. We knew that our first term was 4. Okay. So what we need to do is substitute in a bunch of stuff and try to work our way out of it. So we know that it's going to be 175 is going to be n times our first term, which was 4, plus whatever our last term is, over 2. Okay. Well, what do you do now? What are we going to do now off of that? What are you going to work your way out? No. What do you know that is the nth term? You have that. Okay. Here's what happens. I'm going to get rid of the divide by 2. You be okay with that? Yeah. What can I do within the parentheses? Combine them out.
Both sides by 2. Substitute a and.
I just multiplied by 2. And then I substituted the a sub n because we know that the nth term is 3n plus 1. Okay, because I knew that has to be, whatever that last term, that nth value, whatever it is, it's going to match up to that formula. Now you have a factoring problem. I know you guys love this. Now, here's where it gets to be nice with the fact that we have calculators. Can't we just put that in there and find the zeros?
Okay.
Because it should wind up being an integer value, right? Because you need to have an integer here, don't you? Yeah. I mean, one of them probably won't be, but the other one should be. So we throw that in. So every time I dock, something changes spots where things are. Excuse me. Okay, 0 at 10. It's convenient. So it should be 10 then, right? Because if you go back around, that's the positive, means the other one's probably negative. Turn them away. Now it was somewhere between negative 11 and negative 12. So that's how that would work. It's nice to have a calculator that can do things, especially when you have to factor some numbers like jump. Okay. What we just did here is we factored it to figure out where the zero is going to be at. It's going to be at 10. So it's got.
We don't have to worry about that.
No, because can you have a negative? We're not going. Can you have a negative number within a? I mean, you can have a negative number in a sequence, but can you have a negative, like nth term being negative? That's what we do. Okay. And that's where this stuff goes. We don't have all that much time to go through the rest of these. Let me give you those. All right. And I think you might have done a couple of them already. So I'll be real quick on some of those. Excuse me. So these are going to be all the arithmetic ones. The ones that'll be the goofiest are the last group where you have to find that, like we just did with find the last value of the term where you have to distribute out. Also, sometimes it can get a little squirrely when you have two terms within a sequence with the system of equations. Just be careful when you're distributing out and watching your signs. That's about the biggest mistake people are going to make when they mess those things up. Okay? These are awesome. These are your friends. Excuse me.